Welcome to another session on what, why, and how by Stats ST. This tutorial will tackle calculation of regression equation using the deviation method. I hope you watched my first video to understand what and why to use a regression. Just to recap, regression is a statistical method used to examine the relationship between one dependent variable and one or many independent variables. Normally, y is your dependent variable and x is your independent variable. Look at the example on your screen where I am looking at finding a relationship between price and sales. Intuitively, you would know that price affects sales. So if you notice, as price increases, the sales is decreasing, and as price decreases, sales increases. This is depicted using a downward sloping line in the scatter plot, which shows a negative relation. Intuitively, this is same as the law of demand, which says that as price increases, the demand decreases. We are not only interested in the relationship or positive or negative, but we want to actually predict the quantity of sales if there is a change in price. And that is wherein the regression equation comes into picture. So if I denote sales as y and price as x, I'm interested in a regression equation of y on x. The equation is denoted by y is equal to a plus bx. A stands for a constant. So even if the price were to be zero, still there would be some sales which would be your constant, and b or beta coefficient or regression coefficient can be understood as a multiplier which when multiplied with the independent variable will predict the value of y. How did I get this equation in grade? This was calculated by using a software, Jamovi. Maybe I will show you at the end how to use a software to calculate this equation. But can I calculate using a pen and paper? We certainly can. This calculation is helpful for students for management, BCom, BBA, MBA, plus 12, or anyone who's giving a competitive exam. So let's proceed. I have put up the table and the observations for price and sales. It's easier to calculate the equation for a smaller number of observations, say 10. But if you have, say, 50, 500,000 observations, then the software might be a better tool. But here we are understanding how it is calculated using a pen and paper. To calculate, we have two equations, y on x and x on y. So maybe in the university, the question might be obtain the lines of regression. So that question would have two parts, a regression equation y on x and equation x on y. Now so we will only first look at the regression equation y on x. The equation is mentioned here. If you see y minus y bar. Y bar stands for the mean, arithmetic mean of y. So if you look at the table, the total sum of y is 6660. If I divide it by the number of observations, y bar would be 666. Byx is the regression coefficient which we will follow or we will calculate using this method. It looks complicated, but it is as easy as chewing a candy. And then you need x minus x bar. X bar is your arithmetic mean of x, which is 919 divided by 10. Now, coming to the formula for byx, if you see, it shows n multiplied by dx dy minus dy upon n dx square minus dy square. On the opposite side, it would be dy square. Now, what is dx and dy? I will show you how to calculate in the next slide. So, once you have written your column, make another column dx, and dx would be x minus a. You can also take x bar or the actual mean. In this case, I've taken a assumed mean of 90. Take x1, that is 103 minus 90. So 103 minus 90 would be 13. 98 minus 90 is 8. 85 minus 90. Now I'm subtracting a bigger number from a smaller number, so I will get the answer minus 5. Do not ignore the sign. 92 minus 90 is 2. Similarly, you find all the values of dx and add them up. Now next, I need dx square. So dx square is nothing but the square values of dx. So 13 square is 169, 8 square is 64, 25, 4, 0. Now next I need dy. dy is y minus a. How do I find? 500 minus 670 is minus 170. Take a square of that is your dy square. 610 minus 670 is minus 60. So the square of that would be 3600. And finally I have dx multiplied by dy. So take say 13 multiplied by minus 170 is minus 2210. So if you see, if you multiply a positive number with a negative number, the product would be a negative number. So you would have to calculate individual values for x1, x2, x3 and similarly for. I have done that for you in my table. So if you see here, the table mentions the dx, dx square, dy, dy square, dx and dy. I am more interested in finding the beta coefficient. So I start my calculations here. I am finding byx, not bxy. Byx, the formula is 10 multiplied by minus 3790. What is 3790? It is summation dx dy minus summation dx is 19, and how much is summation dy? That is minus 40 divided by n dx square, that is 343 minus 19 the whole square. A point of note, whenever you're solving an equation, please open the bracket first, then division, then multiplication, then addition, and then subtraction. So I do bracket open. 10 into minus 3790 is minus 37900, and minus 19 into minus 40 is plus 760 divided by 3430, that is 343 into 10, and 19 square is 361, so minus 361. Further solving, so 37,900 minus 37,900 plus 760. So your answer would be minus 37,140 divided by 3069. So my beta coefficient is not 12.1, but it is minus 12.1. Now I will go ahead and calculate the equation. So the equation is, if you see here, let me come here, look at my cursor, it is y minus y bar byx x minus x bar. Let's write here y. How much was y bar? It was 666 equal to minus 12.1 multiplied by x minus 91.9. Let's open this here. So minus 12.1 into x is minus 12.1x, and minus 12.1 into minus 19.91.9 would be a positive number, that is 1112, and I move minus 666 to the right hand side, so I take plus 666. So y is equal to 1778 minus 12.1x. So this is your constant and this is your beta coefficient or the multiplier. If you check in our previous slide, this is what the software had thrown up, and even our results are the same. Take a minute and solve and find the regression equation of x on y using the formula bxy. I have solved this for you. 10 into minus 3790 minus 19 into minus 40, which is the same as a previous one. The only change is rather than n dx square, we have taken n dy square. So that is 10 into 79,800 minus and dy the whole square, that is minus 40. If I solve that, I get a regression coefficient, that is dxy is minus 0.46. And if I solve the equation, I get x is equal to 122.536 minus 0.046y. So in summary, if you see that these are my two equations, y on x and x on y. Now, if I want to predict what would be the value of y given the value of x, that is 600, I put it in the first equation and the value of y is 5482. Let me also show you how this can be calculated using a software. For this, I will be using my Jamovi software. So let me go ahead and open Jamovi. You can easily download this. It is an open source software. SPSS would equally work fine. A soft, a soft, a soft applicable when you have large number of observations or you want to find out the values for equations. Maybe Jamo, 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 maybe Jamo to load, to load. Yes. Now that I have my software, I would open my data file. The data file would be your Excel sheet where you have individual observations of X and Y. So I've opened data set 1. So this is my data set. X is my price and sales is my Y. I'm interested in finding the relationship. Only one thing that I need to change is that I can do any calculation using a continuous variable and not a nominal variable. Same thing, I would do it for sales. Okay. So now I go to regression. I go to linear regression. I need to specify which is my independent and which variable. So sales would be my dependent variable. Price can be my variable. Let's look at the output here. The output would be shown in the right hand window. If you notice here, minus 12.1 is your beta coefficient, which we found out using pen and paper, and 1778.1 was the constant. You can do by interchanging sales and price. So, to summarize, in this session, we have calculated the regression equation using a pen and paper method using the deviations method. There is another method which is the least square method, which I will teach you in our next session. If you've liked this session, please subscribe to my channel or click on the like button. Thank you.